guys, today we're going to be looking at target 5C. And with target 5C, we're looking at confidence intervals. And what that means is basically kind of going back to what statistics is all about, is trying to figure out how much of a population is going to do something, or how often they do something, how long they spend doing something, right? Since we just use a sample of the population, we don't use the entire population, we can never be 100% accurate. So when we do statistics, we've taken these, what we call a margin of error, and then use that for our confidence interval. And we usually say, okay, I'm like 95% confident that this is what's going to happen. Okay? So no one will ever say they're 100% confident. You can't be. But usually we try and get like 95% confident. So in order to find a confidence interval, we need to know our margin of error. So we have two different formulas. And they're used in two different cases. So the first one from a sample population, this is when you're asking like a yes or no question. Do you like pizza? Do you go to the gym? Right? Things like that. Then you say, okay, in my population of, I don't know, let's say 300 people, 180 of them go to the gym, okay? So the sample population is a yes or no question. In that, P equals number of yes responses, or number of favorable responses, and then N equals total population. P equals number of yes or favorable responses, and N equals total population. The other thing we have is from a data set. And this is kind of what we were doing. This is when something has a mean and a standard deviation and all of that. So instead of asking, do you go to the gym, right, and just saying yes or no, I would maybe ask how many hours or how many minutes do you spend at the gym a week, right? So some people would say, oh, I spend 120 minutes at the gym. I spend 180 minutes at the gym. I spend 140 minutes at the gym, right? And we get that, and then we can say, okay, the mean time is 120 minutes with a standard deviation of 16 minutes. All right, so it's not a yes or no question. It's more like a number question. Okay? And in that, S equals your standard deviation, and N is still your total population. Okay, so how many people you ask, how many data points you have. Okay? So those are just your formulas. You will not need to memorize your formulas, but you will need to know which one to use when and what those letters stand for. Okay? Once you find your margin of error, you can find your confidence interval. Okay? The confidence interval is the probability that the population will fall between those two values. So it's kind of like what we were doing yesterday when you took the mean and subtracted the standard deviation and added the standard deviation. All right, but instead of that, now we're subtracting the margin of error and adding the margin of error. All right, so it's your population that said yes minus your margin of error, your population that said yes plus your margin of error. Okay? So it's kind of the same thing for both of them, but they use different symbols. So this symbol is just your population. We have our margin of error here. This we call mu. How to pronounce? MU. Mu. And that just is kind of like what the numbers that fall. It's your like average mean almost. But it is just pronounced mean. When we have a data set, instead of subtracting from the your population that said yes, right, we're subtracting from your X bar, right, your mean of that data. Okay, and again, we pronounce that letter mu. So let's look at an example just to see how this works. Okay. If we look at example 1, right, this is a data set. I am given a set of data with numbers. Okay, so I have to find the mean and the standard deviation. Sometimes you'll be given the mean and standard deviation, so just know if it's anything to do with mean and standard deviation, you're using the data set one, the one that looks like this. Okay? So the first thing we're going to do is find the mean and that standard deviation. For the sake of time, this is a lot of data, I already found this, or this is what was on our quiz as well. It's just typing it all into your calculator. So our mean, our x bar, is 6. Our x bar is 6.35. And our standard deviation, right, that looks like this. Our calculator is 5.25. Then B is asking me for the approximate margin of error. So that's using this equation here. Okay? So our margin of error equals 1.96 times our standard deviation over the square root of n. So that is 1.96 times, well, my standard deviation we found to be 5.25 all over the square root of and n. I'm really just counting up these numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18, 19, 20, right? So my number of numbers I have is 30. And then I'm just going to type that straight into the calculator. So I have 1.96 times 5.25 divided by 30. And when we do that, we get 1.8. 1.88. Okay? So that's my margin of error, 1.88. Okay? So we could say, like, we know that, right, our wait time, which our mean was 6.35, well, it can either be 1.88 minutes less or 1.88 minutes more than that. So our confidence interval is we take what, in a data set, we take our mean, right, so that's 6.35, and we subtract the 1.88. That's our low end. So that's less than or equal to mu. It sounds like a backwards y, which is less than or equal to, and then we take 6.35 and we add 1.88. So then I get 6.35 minus 1.88 is 4.47. Which is less than or equal to, and then 6.35 plus 1.88 is 8.23. So what is the meaning? The meaning of this is, and this will always be written pretty much exactly the same way, 95% of customers, 95% of customers will wait, right? And then you're really just saying what it is. So this is wait time in a grocery store. So there's 95% of customers will wait between 4.47 minutes and 8.23 minutes. So your content is really saying 95% of everyone is going to fall between these two numbers. Okay? All right, let's look at one more example. Let's look at an example with our population. So, in a simple random sample of 500 people, 342 reported using social network sites on the internet. So what is the sample proportion? This is our P, right? So P equals, well, 342 reported using social networking sites out of 500 people, okay? So I'm just going to reduce this. And you get 171 out of 250. Or you could also write it as 0.684. Right? You can use either the fraction or the decimal, whatever you find easier. So that's our P. Okay? So then, for B, determine the result margin of error. Now we're using this other formula. So the margin of error equals 1.96, and then square root, P is 0.684, times 1 minus 0.684. All over an n. Well, there's a total of 500 people. That's our total population. So this equals right, typing all of it in a calculator, we should get 0.04. You guys rounding 0.04 about. So then, what is our confidence interval? Okay. Our confidence interval, we use this and this. Those two numbers we just found. So we are going to have 0.684 minus 0.04 is less than or equal to mu, which is less than or equal to 0.684 plus 0.04. Okay, so you add and you subtract that. So we get 0.644 less than or equal to mu, which is less than or equal to 0.724. Okay. And a lot of times with these ones, it's easy. It's nice to kind of push it back into percent at this point. So really, it's 64.4% is less than or equal to mu, which is less than or equal to 72.4%. Okay. So with these ones, the population ones, push it back into percent. And then finally, what is the meaning of the interval, right? Well, and here we are looking at people who use social networking. So, these are a little bit different. For these ones, we say with a 95% confidence, (64.4% to 72.4% of people use social networking sites. So that's your kind of phrase. So as with a 95% confidence, this happens. Okay? Alright, that is all for today. I will see you guys tomorrow.